Hello everyone, welcome to our Engineering Graphics lecture series. Friends, in this session, we are going to solve another problem based on projection of line. So the problem statement is, a line PQ 90 mm long is inclined to HP and VP at 55 degree and 35 degree respectively. Draw the projections if point P is 25 mm above HP and 20 mm in front of VP. So friends, this is special case problem. In this problem, theta and phi angle is given, and if you add theta and phi, so this addition is equal to 90 degree. So this is special case problem. So you will get the different solution for this problem. So first write down the given data from problem statement. So true length of the line is 90 mm, and this true length is inclined to HP and VP. So theta is 55 degree and phi is 35 degree respectively. Draw the projections if point P is 25 mm above HP. So point P is given, it is 25 mm above HP and 20 mm in front of VP. In front of VP. So see the solution of this problem. So we can solve this problem very easily if you know this concept, projection and rotation concept. This is XY. So draw the reference line problem. A line P dash, and this is P dash, this is P, theta, phi, locus of Q dash, locus of Q, Q1 dash, Q2, project, rotate. So if you have the true lane, then project Q1 dash up to locus of A, locus of P, this is locus of P dash, project up to locus of P, and then mark a arc. I'll get a Q point. P joint PQ, I'll get the top view. This is Q dash, this is a elevation line or a front view. So from this reference diagram we can solve this problem. Okay, so mark a point P first. Point P is 25 mm above HP. Draw a XY line. Locate point 25 mm, 25 mm and 20 mm in front of it. So draw the locus line which is passing through A dash, P dash and P. So this is P dash, this point is P, this is called as a locus of P dash, this is a locus of P. Now mark theta and phi degree angle. So theta, you can see if the true length is inclined with the horizontal plane, this angle is called as a theta, and if the true length is inclined with the vertical plane, at that time this angle is called as a phi angle. And this angle we can mark from P dash and P. So place a protractor here, mark 55 degree angle and 35 degree angle with VP. This is 35 degree. By using thin line, draw the angle length first. Take a compass, grounder, and measure 90 mm true length distance of this line. Mark a true length distance on the theta and 5 degree angle line. So this is a front view and top view of a true length. This is a true length. This angle is a theta. This is also true length. This angle is phi. So I'll get a Q1 dash point. It is a true length point. This is a Q2 point. Now draw the locus line. Draw the locus line, locus of Q dash and locus of Q. This line is called as a locus of Q, locus of Q dash. Now we know that if you have the true lane, so project true lane up to locus of P, then rotate it. So I'll get the Q point. So by using projection and rotation concept, we can find the top view. So project true lane up to locus of P. So here I'll get a point Q1. So project Q1 dash point up to locus of P. Now this distance is called as a plan lane distance. Now take a rounder, measure this distance in your compass, P Q1 distance, and mark a arc here. So you will get exactly on perpendicular to this locus line. So here, if you join, this is a Q point. If you join these end points, I'll get the plan length. I'll get the plan length. Project and then rotate. Okay. Similarly here, we have the true lane in the top view. So project this top view true lane up to the locus of P dash. I'll get a Q2 dash. This distance is called as a elevation length distance. Now take a rounder, measure this elevation length distance you compass and mark a arc. Now you can see here the point of intersection is on the locus of Q dash long vertical. So this is a Q dash point and this distance is called as a front view. This view is called as the front view and this is elevation length. This is the top view. Now this is the solution for this problem. Now you can see here if theta e plus phi is equal to 90 degree, at that time you will get the such a type of solution. Now show the dimensions. So dimensions have marks. So give all the dimensions. So we know that the P dash and P heights are given. So it is 25 mm above HP and 20 mm in front of PP. Find the answers. So here alpha is 90 degree and beta is also 90 degree. Alpha, beta. Alpha is 90 degree, beta is 90 degree. Measure the elevation length distance and plan length distance. So plan length is 50 mm and elevation length distance is equal to 75 mm. So that's the complete solution of this problem. Try to solve this problem. Thank you for watching this video.